81% of energy consumed in the United States still comes from fossil fuels. Even through great push for renewable energy, why is this still so dominant? Well, one of the big reasons is just the energy contained in these fuels, and it's valuable because of its ability to create heat. And so the energy contained in these fuels, be it coal, oil, gas, is converted to heat through some sort of process, something like a diesel engine, if you're burning diesel. The problem with this process is that converting it from that heat energy into something more usable, like a kinetic energy or electrical energy, is that process is not efficient. So the average combustion engine is at best about 50% efficient, which means that half of the energy contained in the fuel that's used is lost, typically in the form of waste heat. You lose that heat, that potential energy, that's wasted money. Take, for example, 18-wheeler trucks driven by diesel engines. 70% of the cargo in the United States is transported on the back of these trucks. They make up 20% of vehicle emissions in the United States and face stringent efficiency regulations that require them to become 40% more efficient over the next decade. Another use case, Maersk Line is the world's largest container shipping company, spends $2.7 billion in bunker fuel every year, and it is estimated that the pollution from burning that fuel is the same in terms of sulfur as the world's 760 million cars each year. So how can we fix this? Our solution is thermoelectric waste heat recovery. And so thermoelectric generators have been around for a long time, and we bring patented new improvements to the process that allow us to convert heat to electricity in solid state. So there's no moving parts, which allows us to put these in a lot of different places at a variety of scales and can operate continuously for decades. So the basic building block of a thermoelectric generator is just a simple module. There's one for scale. It's 4 by 4 centimeters, and our module can generate about 20 watts of electricity. We can wire these in series to any scale of power output. So on a truck, you'd see about 75 of those modules, a 15 to 2,000 watt generator to replace something like an alternator. You could do that several hundred times the size for something like a power plant, for a ship, or any realm of applications. And so as a business, what we do is we manufacture these modules and then also turnkey solutions. So we can take just the modules and sell them to systems manufacturers such as truck manufacturers, ship manufacturers, just give them the underlying technology which we own and allow them to incorporate it into their own systems. Or we can build our own systems such as the TR1, which is a heavy truck system that can be installed simply in an 18-wheeler truck, provides a 5% efficiency gain, and I'll go into that here in just a second about exactly how that works and how we achieve that. And then down the road, larger scale, we'll be able to look at things like power plants, ships, trains, and that kind of thing at a much larger scale. So for the truck system, like I mentioned before, it's about 75 of those modules, which fits comfortably in the weight and space restrictions of a truck. The way it works, the way we save fuel, is by disengaging the alternator. So on a truck, right now, you have an alternator that generates the truck's electricity. We can capture the heat found in the exhaust of the truck, just in the normal exhaust stream, and capture enough electricity there that allows us to disengage the alternator that would otherwise be powered by the engine's belt. This removes load from the engine and makes the whole system 5% more efficient. For trucks, which is our initial target market, we look at a payback period of about 1.9 years right now at current diesel prices. And according to price projections in 2018, when we're able to bring that to market, the prices will be closer to $3 a gallon, which is a 1.3-year payback period. The sort of magic number for truckers and the efficiency play industry in general is about 18 months or a year and a half, and we are confident that we'll reach that as prices rebound, and we have something to offer now as well. So like I mentioned, though we have a variety of markets that we could tap into, our first market is by selling modules and partnering with OEMs in the 18-wheeler truck space. Think Freightliner, Peterbilt, companies that make these trucks. The market for trucks in the United States, these manufacturers sell over 300,000 trucks each year, new. And historically, 14% of those trucks have included additional fuel efficiency savings technology that is in addition to what's already installed by the manufacturer. And so that is a $182 million served addressable market for just this fuel efficiency technology on these new trucks alone. By 2020, we aim to achieve about a 10% market share of that served addressable market, which will also grow because of the new efficiency regulations that are required. Right now, we're looking for about $380,000 in seed capital to get this off the ground with real-world market tests. We are still very early in terms of validation, so we are seeking this in terms of grants and business plan competitions, not as much equity because we can't really justify a valuation at this point. We've been competing around the country. We're working on SBIR grants, on ICOR grants, all of the general grants for this kind of technology. And we look to be able to achieve a working prototype by the end of next year. This is our team. My name is JP Dowling. I'm the CEO. Laura Mahaney is a business co-founder, and Dr. Ching Ji is one of the inventors of the technology. The technology was invented at the Texas Center for Superconductivity at the University of Houston, led by Dr. Zhifeng Ren, who is one of the premier researchers in the thermoelectrics field in the world. They invented this technology, and there are two key patents which we're in the process of negotiating an exclusive license to from the University of Houston, which is where I'm from as well. On our advisory board, we have several mentors, including Scott Parazynski, who's a retired astronaut, and currently is a CTO of a new investment firm that focuses on energy harvesting systems like ours. So, large scale, every gallon of diesel burned emits 22 pounds of carbon emissions. By 2020, we hope to be able to help our customers save 3.5 million gallons of diesel fuel and reduce carbon emissions by 81 million pounds. Trucks are just the start, and there are a range of applications for us, including military vehicles, oil refineries, trains, and even jet engines. That's Recollect Energy. My name is JP. Thank you. I'm happy to take any questions.
So your device is a LTA device, essentially?
Yes.
So the 22% conversion efficiency's been around for a long time. What makes your product unique or differentiated?
When you compare ours to other products on the market right now, Alphabet Energy is a company that makes very similar products in the high temperature range. So we operate above about 300 degrees Celsius.
That's the hot side?
That's the hot side, yes. And so most thermoelectric generators that are around, bismuth telluride devices, work at a much lower temperature. For those that are available at this high temperature, they're not able to generate the same amount of power output in the same space. So if you were to take other commercially available generators, modules that look very similar to ours, we can provide twice as much power output per area, per volume as they can, which allows us to do things like trucks, where it's less feasible for them because their generator would have to be twice the size, twice the weight, and so on. Does that answer your question?
I probably have lots more questions.
I'd love to talk to you about them.
Are they, is the IP, is it composition of matter, or is it method patents?
I'm sorry?
Your intellectual property, are they method patents, or is it composition of matter?
Both, actually. So there are two. One is for one patent covers both the method and composition for the materials, and we have another one which involves building those materials into the actual module. So there's two patents there in both.
So you actually have material that is owned by the company also, is proprietary
Yes.
to the company.
Mm-hmm.
And that allows you to get to that higher heat without like
Right.
disintegration or whatever.
The very secret sauce of any sort of nanomaterial that works as a thermoelectric generator is that it conducts heat slowly and electricity quickly. So it's a thermal insulator and an electrical conductor. And we have a compound that's a range of very specific compounds that make that up.
So I think I'm getting to it from the last two questions, but maybe another way of asking the last two questions. When I Google waste heat recovery diesel engine, I get 485,000 results. What's different about yours?
About ours? Well, so if you look at waste heat recovery, typically most of them are mechanical systems. And so you've got things that break down, things that over time will incur greater maintenance costs, which is something as a truck fleet, when you're evaluating technologies, to include anything that takes a truck off the road because it adds another maintenance component is something that costs you a lot of money. Because ours, thermoelectric generators specifically, as a device, don't have that same component, because they're all solid state, and so the maintenance cycle is much more controlled, and there's not a need for any fluids or mechanical things to be changed. Now, there are no currently available thermoelectric devices for these heavy trucks that we've been able to find, and so that application that's really our selling point there, in addition to the efficiency.
So I only get 36,700 thermoelectric waste heat recovery diesel engine. Point is, you're gonna need
I haven't looked at all of those.
But you're gonna need a one sentence about what do you have.
Right.
I don't know what you have.
Thank you.
And I'm not an expert or even an armchair understanding of the area you're in, but it would seem to me that part of what you're competing with are other completely different approaches for fuel efficiency or reducing the cost of operation, right? So that if you're a trucking company, you've got a bunch of things you're considering, including buying, new trucks instead of old ones, or lighter materials for the trucks, or other things. So you're going to somehow be best where the extra efficiency is beyond the other things they have as alternatives, or they haven't already done. Have you thought about whether trucks versus, as you said, jet engines, or some of these other areas where they've essentially exhausted, no pun intended, the tricks they can apply, and they still need to find more, and that's where you come in play, so that you kind of break through the noise, if you will, of all the other things they can spend their money on?
Yes, thank you. So one of the things that's tricky about this kind of system is that there are so many applications. We haven't exhaustively ruled all of them out, and so that's something we want to work on this summer. We had some really interesting talks with Maersk, the shipping company, that may prove to be more fruitful in the long term. One of the things, though, that is exciting about trucks is that because of the regulatory pressure they're under, this 40% over the next decade, every single layer of technology that can be applied will end up being applied. I talked to a guy at Mack Trucks for a long time, and Mack as a company is vertically integrated, so they control their entire truck much more tightly than many other companies do. And they're looking for 0.5% increases on things like this. They're squeezing everything they can out of, and for us to be able to offer something like 5% is notable. Also, most of the other technologies work as well. So aerodynamic technology is something on a truck that makes a lot more sense than ours does. It's cheaper, it pays off faster, and it doesn't break because it's just wind resistance. Almost everybody has those now, and so now they're looking for the next thing, and these all stack on top of each other. So it's not that we are directly competing, it's just in what order we are. And so those are a great point, and that's what we look forward to exploring this summer.
2 minutes.
So how do you compare to other combined cycle type of power plant you're talking about, to like steam turbine, conventional, very conventional, tried and true technologies that could be employed, like say diesel trucks? It's not magic. They could fly a steam turbine, probably get pretty good efficiency out of it. How do you compare to that? If they go down that route where they're trying to, they're going to go and do that combined cycle, and there's other technologies, how do you compete? And where's the break-even points on follow-up to that? Is how do you scale for cost versus the power output?
Right. And that's the second part of that is a really good question. I don't have a perfect answer to yet, so I'd love to sit down with you and kind of draw that one out.
So I think that's
on the first part. In terms of steam turbines, so steam turbines are vastly more efficient. We achieve about a 10% conversion efficiency, but we're able to do so at a much smaller scale, and it is a much more stable device, and that's been our pitch so far. And so you see things on engines like turbochargers, which are essentially a similar kind of turbine. We work in conjunction with those, so a turbocharger on a large engine will capture a lot of that energy, but there will still be enough left for us to be able to harness it. So it's not necessarily that we have to beat out everything else, but that we find a way to work all of that together. That's not a perfect answer to your question. I'd love to work towards it over the summer. Sir?
Last question.
Kind of focus a little bit on how will you get noticed? Because there's a huge play of how will you differentiate yourself from the entire market. But I think you have to kind of figure out what's that value proposition for each of your different target markets that you're going to really focus on. So I think it's just wide in terms of what you're trying to accomplish. I really think if you really kind of focus in that specific space, what you want to do, what's your story, that would really help you.
Thank you. And that's the challenge of this technology that we're still working on very much.
I'd like to follow on that as well, because, Isaac mentioned 485,000 hits, and I think I've seen half of them. So waste heat recovery is absolutely a technology that's gonna happen, and you're in a good place. I've seen everything from laptops to, to all kinds of, power plants, glass plants, what have you. Any place that has waste heat. The challenge almost is it's too big. And the challenge further is that there's all kinds of people in this space. So you really need to be differentiated in your technology. From what I gather, this is differentiated enough because of the delta T that you talked about. I don't see that being extraordinary. But you mentioned Maersk as being interested in what you're doing. So if you can hone in on one very specific place, because the problem to me is your universe is too big, you can't address that universe. You need to address something, and Maersk sounds like a great place to go address, because their slide of their sulfur emissions is staggering. Anything you can do with them gives you a great platform to launch into the next thing.
Thank you, and that's one of the things we're very much pursuing. All right, thank you, everybody.
Thank you.